In this class, we're going to be looking at the concept of chiral carbon. And what will I be teaching you? I'll be teaching you what is a chiral carbon and how to identify a chiral carbon. If you look on the board, we have a carbon atom attached to a bromine atom, a chlorine atom, a fluorine atom, and an iodine atom. All these atoms are different from each other. And so when we have a carbon like this that is bonded to 4 different atoms, we say the carbon is either chiral or asymmetric. So simply put, a chiral carbon is a carbon bonded to 4 different atom or substituent group. A chiral carbon is a carbon bonded to 4 atoms or 4 substituent group. Now, let me show you how to identify a chiral carbon in a given compound. Now, first of all, I want you to know that when you have a CH3, that carbon is not chiral simply because we have already 3 hydrogen atoms attached to this carbon that are the same. Remember, a chiral carbon must have 4 different substituents. Now, when you also have a CH2 group, there are 2 hydrogen atoms here already that are the same. A chiral carbon must have 4 different substituents. So when you have a CH2, a CH3, just know that that carbon is not chiral. And if you see a compound, first of all, you mark it out. So if we come to this compound, we have a CH3 here, so it is not chiral. We have a CH2 here, it is not chiral. We have a CH3 here, it is not chiral. Now let's look at this one that has CH. It is bonded to an ethyl group, that is CH3CH2. It is bonded to a methyl group, bonded to 1 hydrogen, and bonded to a bromine. Ethyl is different from hydrogen. Hydrogen is different from methyl, and methyl is different from what? Bromine. Therefore, this carbon is what? The only chiral carbon in this compound. Now, let's move to this compound. I'll call this compound 1, this is compound 2, and this is compound 3. Let's move to compound 2. Remember we say CH3 is not chiral, CH2 is not chiral, or you say they are chiral. Now, that means they are not optically active. Now, let's move to this. And also I forgot to tell you now, remember that for every chiral compound, there are sp3 hybridized. If you go through my channel, you see a complete lecture that is pinned on what? Hybridization. Now let's look at this compound. On this one, CH3 is not chiral, CH2 is not chiral, CH2 is not chiral, CH3 is not chiral. Now let's look at this. It has a CH, so this is an atom. But on this side, okay, chlorine is a different atom. On this side, I have CH3, CH2. So this is one group. And then on this side, I have CH2, CH3 attached. This is another group. And so because this CH3, CH2, CH2, CH3 on both sides are the same, this group here and this group here are the same. Therefore, this carbon too is not what? Chiral. Therefore, on this carbon, there is no chiral carbon. Let's move to compound 3. On compound 3, we have CH3, it's not chiral, CH2 is not chiral, CH2 is not chiral. We have a CH, okay, CH3 is not chiral. So here now we have CH. So this atom is attached. That is the first substituent. Second substituent, bromine, is different. Methyl is substituted, is different. And then this, propyl, is different. Therefore, this carbon is what? Chiral. So that is how to identify a chiral carbon in a given compound. You just follow this simple step and you get it correctly. If you have any question or contribution, you can leave it in the comment section. If you have a question, drop it there. Please don't forget to like this, share, and comment. Thank you.